Did you know that we have made liquid telescopes? They are super weird, but very cool. So here I've got a little reflecting telescope, and the way it works is light comes in here, bounces off that big mirror in the back, then off of this little secondary one into the eyepiece. In order for this telescope to work, that big back mirror has to be really smoothed, and it has to be curved in a specific way such that it focuses light into this secondary mirror. And that process of shaping and smoothing the mirror is really difficult and time-consuming, especially when you want to make big mirrors for big telescopes. But if you take a liquid and you spin it around at a constant speed, it will form a nice parabolic shape, the exact shape you need to focus light. And if that liquid is reflective, like let's say liquid mercury, you've got yourself a nice little telescope mirror. So people did this. In the 90s, there were a few smaller ones, but in the early 2000s, the University of British Columbia built a 6-meter liquid mercury telescope. This is what it looked like, and it worked. They got this image of the night sky. But there were some issues. For one, there was a lot of interaction between the mercury and the air above it that caused ripples on the mercury's surface. So they added a very thin film of mylar over the whole mirror, but that kind of reduced the image quality. Also, this telescope was in British Columbia, which is famously kind of rainy and cloudy and not an ideal location for astronomy. This was much more a test of making large liquid mirrors. More recently, we got the 4-meter International Liquid Mirror Telescope in India. And this one is actually being used for science. Here's some images that came from it. Design, one of the biggest limitations for liquid mirror telescopes is that they can just point straight up. They can't track objects as they move through our night sky. This is the building that houses the International Liquid Mirror Telescope, and you can see they just kind of open the roof and anything that's right above it is all they can see, meaning they can only observe an object for about 100 seconds every night. But that doesn't mean it's not useful. Because the sky over this doesn't change that much from night to night, they can look for things like transients or objects that change over time, they can track satellites or space debris, and liquid mirror telescopes are a lot cheaper than solid ones of the same size. They're obviously not a perfect technology, and like liquid mercury isn't that safe to work with, but it's still really cool that these exist and work. NASA's currently looking at a space-based liquid telescope. People are thinking about putting these on the moon. It's a really interesting technology. So we'll see if we get more of these in the future.